Hello everyone. So in the previous video we saw binary exponentiation and its application, and in this video we will see Fibonacci numbers. So let me first define some notation. So capital F of n will denote nth Fibonacci number. Number is nothing but a sequence of numbers whose nth Fibonacci number is denoted by f of n. Now we should remember three things: that f of 0 is 0, that is 0th Fibonacci number is 0, and f of 1 is 1, and the nth Fibonacci number is f of n minus 1 plus f of n minus 2. Means the nth Fibonacci number is obtained by summing up the previous two Fibonacci number. So how the sequence will look like? So the first one is 0, then 1. Now for the next one you add this 0, 1, 1. For the next you add this 2. For the next one, add the previous two, 3. You keep adding and you will get the next Fibonacci number, 8, 8, 5, 13. Right? So this is how you get the Fibonacci number. So how you will code this? Let's suppose I give you a question that find the 400th Fibonacci number. What is the 400th Fibonacci number? How will you find this? For this, you need Fibonacci value of 399 Fibonacci number and value of 398 Fibonacci number, right? And for this you need 398 and 380, 397 Fibonacci number. So uh, how will you do this? Uh, First, make an array of length n in which you will store the Fibonacci number. So you know the first Fibonacci number 0, second is 1. Now simply you keep adding the previous two and update here. Keep adding, and when you reach the 400th index, you just print the value of this, right? So let me see you the code. So in the input, I will give you n, and let me define the vector f, which will store the Fibonacci. Now Fibonacci of 0 is 0, and Fibonacci of 1 is 1, right? Now for the next, from index 2 to n, Fibonacci of I will be Fibonacci of I minus 1 plus Fibonacci of I minus 2, and you just output the Fibonacci of n, and that is your answer, right? So let me take test case also. So four test case: fifth index, second, fifth, 100, 400. So here the second Fibonacci number is 1 and fifth Fibonacci number is 5, right? Fifth Fibonacci number is 1, 2, 3, 4, and 5, 5, right? And the 100th Fibonacci number is this. Now you can see that 400th Fibonacci number is less than, because an overflow occurs because the number is increasing, is getting bigger and bigger very quickly. So let's see the 40th Fibonacci number. Yeah. So basically the 400th Fibonacci number exceeded the limit of long long. That's why it's it's get rounded off, right? So for if anyone is asking the 400 Fibonacci number, he will ask 400 Fibonacci number modulo some number, right? So I will ask modulo n. Capital N is basically 10 to the power 9 plus 7. Now I can ask the 400 Fibonacci number and it will not overflow. Yes, right. Now let's see the second thing. If I am asking you the 400 Fibonacci number only one time, do you need to store the complete array? No, you just have to store the previous two values, right? And for getting the next value, you just add two, remove this, and keep this two index only. Keep two value only. Means let's suppose 0, 1, next number will be 1, next number will be 2. So for calculating this number, do you need this or this? No. So why are you storing this? Don't store this, right? So you can simply store the you can do this in three variable. Maintain A, B, and C. Initialize A with 0, B with 1, and for C, add A plus B and replace A with B and B with C. I will show you the code. And also, let's suppose you are given multiple test cases. So in every test case, you don't have to calculate this. You can pre-process this. Means you can, let's suppose the maximum value of n is 10 to the power 5. So 2 into 10 to the power 5. So you declare up to here and you pre-process this here and just simply output the f of n. And you will get the all of the output in O1 for all each n, right? Now let's see how to do in using only two variable. I am, let's suppose I give you only one n per test case. So you take the input n and you maintain two variable, three variable int a, b, and c. Initialize a with 0 and b with 1. Now the value of c will be a plus b. The c represent the ith Fibonacci number. And now update a and b. So a will be b and b will be c. And your final answer will be stored in b, right? Let's see. And also take the modulo. C modulo equals to n. Let me keep this value here. No, oh, there is no test case. Just take the test case also. Yeah, it's passed. But this is not applicable if you are given multiple n in one test case only. You have to do linear time iteration in for each n, and that is not recommended here. So you can just simply maintain a vector and store it. Now for n less than 10 raised to power 7 or 8, you can do this. You can keep a vector or something like this and you can find the n Fibonacci number. But what if n is 10 raised to power 18? How will you find the Fibonacci number, n Fibonacci number modulo m? How you will do this? So here comes the matrix exponentiation. So you see that the n plus 1 Fibonacci number is basically f of n, plus f of n minus 1. Can you write this in a matrix form? Let's try to write this. So f of n plus 1 and f of n f of n and f of n minus 1, right? So f of n plus 1 is basically f of n plus f of n minus 1. So if you sum this up, you will get f of n plus 1. So I am putting 1 comma 1 here. So if you multiply this, you will get f of n. And for f of n, just you need this in this value. So 1 and 0, right? Now you can simply express this also in the same way. Let's denote this matrix by capital A. So capital A. Now when you rewrite this as you wrote this, you can write this as A multiplied by f of n minus 1 and f of n minus 2, right? So if you keep doing this, you will find that this it will go up to f of 1 and f of 0, right? So, and what's the count of this? This is n plus 1 and this is 1. So if you put n equals to 1, then you will get here f of 2 and you have to multiply it with 1. So this is in a raised to power n and f of 1 and f of 0. And this is f of n plus 1 and here f of n, right? So you can see that if you convert a is 1 1 1 0, right? So and you know the value of f1 comma 0, that is, so let me write clearly, f of n plus 1 and f of n is equals to 1 1 1 0 raised to power n multiplied by f of 1, value of f of 1 is 1 and here it is 0. So this is the expression that you get, right? Now if n is very big, then you just have to calculate this one. Whatever you get, you multiply it by this and you find this index, find this value. So and you can do it very easily, uh, just like binary exponentiation. That this is basically matrix exponentiation that I will tell you in the later videos. So this is how you can find f of n plus 1 easily. Now there is one more reduction uh, that is basically if you do some observation, then you will find that this is this you can reduce this by this, that is simply take the nth power and uh, this element is your required answer in the Fibonacci number. So let me show you the code. So this is a matrix of 2 cross 2 and I am defining a operator multiplication which just take two matrix and multiply it and give the result. So the matrix power, basically it is a matrix exponentiation which take base raised to power n. So if you give it this function, this matrix, and this n, it will give you the value of this raised power n, right? So I'm giving this and n, and it will do exactly like bind the exponentiation. If the current bit is 1, then it will multiply the base. It will take the square of base and divide n by 2 and return the answer. And for finding the Fibonacci of n, our base is 1110, and the answer will be base raised to power n, and the index will be 0 comma 1, right? This is a 0th row and 1th column, so 0 comma 1. And now this is your answer. So this is very simple. Just take the input n and print the output. C of Fibonacci of n. First, see whether it's working. Also. So yeah, it's fast. Now let's take a very big value and check whether it's able to compute or not. Yeah, it's uh, it's very fast. It means the time constant to do this is log n, log n multiplied by some constant, right? So in the next video we'll see some problems on Fibonacci numbers, and you what in the competitive programming, if you are learning some algorithm, then learn it and then make a template, because after 6 months 7 months you will forget the algorithm, but if you have the template, then during the contest you can easily apply that. You don't have to see here and there for finding the algorithm and learning it. You can't do this every time. So just make the template, save it. You can take my template also. Thank you, and the next video we'll see the application.